and lots of participation today. So people writing stuff on the board. You don't want to be Dennis and have to say over and over and over again the same thing. It's not fun for us, not fun for you guys to listen to. So let's see. Aiden, Alejandra, Angel, Anne Marie, Ashley, Brianna, Chantel, Haley, Jaylen, Kevin, Mario, Morgan, and Ziggy are here today. Yes, thank you, Morgan. Thank you, Ziggy. Appreciate that. Appreciate your participation. And moles are not just animals. That's true. That is very true. They have a very important role in chemistry. Not a fuzzy animal lives
Another,
underground.
this
They're
would be
itself a
a
unit
kind
of
of a
nature.
light bulb, and then
So good
obviously I have
observation
another
there. I
one
like
right
that.
here that
Okay, good
already
morning,
has
Haley.
a
Good
light
morning,
bulb
Kevin.
in.
Yes,
So what
appreciate
I'm
you
going to
guys
do is
being
I'm
in
going
the
to
class
connect
today.
my
Okay, so
connectors
I'm going
here
to
to
go ahead
make
and get
a
started here.
series circuit first. And
We're going
so when
slide.
I
We're doing some
connect my
personal
connectors to
informations
make
and
my
lots and
series
lots and
circuit,
lots and lots
you
and
will
lots
notice
and
that
lots.
right now
Today,
it's not going to work.
especially,
Why
we
is
want
it not
lots
going?
of participation. So this is really what we want. I'm not sure why I disappeared, but there we go. That's what we want for sure. So very, very, very extra super important. And of course, this is going to be recorded for students that may not be here and just to do them for educational purposes. Okay, here we are, guys. Day 55. Look at that, 55 out of 60, getting very, very, very close. Nice. We are on the 8th of November, and guess what Thursday is? Thursday is going to be a holiday. Probably shouldn't have put down a red square. That might be a little bit confusing there. That's going to be a holiday, right? So we're actually going to have a short week. So we want to take advantage of every single day this week for sure. All right. It is nice actually. How many days left? How many actual school days left in this trimester? How many school days left in the trimester? Yeah, 6, right? Some like us said 5 because we're like, well, we don't count today. But yeah. So we're getting really close here. Your notes here are going to be notes 5H. So go ahead and get those notes open. Click on them, get them open. Thank you, Ziggy. And get your hand up. Get your arm up. All right. Thank you, Morgan. Thank you, Ziggy. Get your hand up, guys. Hands up, hands up. Air out those armpits, guys. All right, Haley, thank you. Okay. Nice, Ashley, nice. Something to hear from Mario, Kevin, Jaylen, Erica. All right, Emery, thank you, Emery. Thank you, Kevin. Okay. What do we still need to hear from so we can move forward? Don't slow down the boat. Okay. Okay, I'll give you guys a few more minutes of that. So we're going to talk about organic chemistry, or OChem, if you take this in college, organic chemistry. I personally think it's super interesting. This is an area of chemistry I actually enjoy. If you take it in college, it can be a difficult class. It's not necessarily an easy class, but I think it's just pretty fascinating. So organic chemistry, and again, there is no what. There's no what. No, it starts with a P, ends in ROJECT. We have no what this part of the class. Put some feedback here, guys. No what. We don't have a project. Yes, please. Yes. No project. So if you haven't done the project, you have some projects you still need to do them, right? I have no other way to say it than that. So they're worth lots of points. This sort of helps you remember the class as well. And we'll have our final exam. Okay, so go ahead and get started here. Click on your OK box. Speaking of OK. Now today we're going to do basically two things in general. So we're going to talk about what are organic molecules? What are they? Like, what is an organic molecule? Something you buy in a health food store? No, it's not that. It's something else. And what's the difference between a monomer and a polymer? So there's some cool sounding words there. Figure out what those are as well. So I promise not much math today. Okay, Miss Bolt has some very important announcement here for you guys now.
All right, so this is an important announcement because it really is important to know that you understand all of this. I will be zeroing out all the work this afternoon, and you will see your final grade without the final exam. So that means I'm going to actually zero out the final exam also. So with that being said, this will inform you on what you need to do these next couple of days to raise your grade. Those of you who have been here, have been paying attention, have been getting their stuff in, you guys have been doing excellent. But there's a few of us that need to really kind of focus in and really kind of pay attention to see where we need to be. Once I zero out your grades, all of them, and that's including your final exam, that means that you have a starting point of what you need to do, because at that point, you cannot have your grade any lower. You can only benefit your grade if you turn something in. Okay, at that point you can only raise your grade and it's no longer can be lowered. Okay, so make sure that you understand that. Those of you who are doing really well and I zero everything out, including the final exam, and you're like, and you look at your grade and you go, OMG, I have a C now. I had a B. It's because it's because we need to do the final exam. With that being said, the final exam is going to be tomorrow. The next couple of days, we're going to be going over that final exam together. So make sure you are in class and you are participating. If you are not participating, then this is going to be very tedious and it's not going to be very fun. It's not going to be like notes where we're going to give you the answers. It's where we're going to review each question and we're going to then give you some time to work on it. Remember, this is only on Unit 5. I am not going to test you on Units 1, 2, and 3 and 4 is because you've already demonstrated your mastery with your projects. So this is only going to be for Units 5. I'm going to be zeroing them out this afternoon, okay? So I'm going to be zeroing out everything we've done so far, or what we're going to be doing. That's the final exam. That's our Unit 4 that we've already should have turned in, and that's today's notes, okay? So everything's going to be zeroed out. When I zero it out, that doesn't mean you can't turn in anything. You have technically until November 17th at 11:59 to turn all your work in. So use that time wisely. And next week, at the end of this week and next week, we're giving you time to work in class. You can use us as a resource if you need help or anything, but it'll be a work time for you in class. So just kind of be aware of that. Okay, Ashley? Don't panic if your grade drops. It just means that we have to do the final exam, which we're all going to be doing tomorrow and on Wednesday. Okay, we're going to do it in 2 days. So, that hopefully you are good, and if you have any questions, please email Mr. Corniola and I, and we would be happy to help you out with those questions. Okay, all right, let's go ahead and move on and start our lesson.
Okay, so let's get started here, guys. So organic chemistry means compounds formed with carbon. So carbon is one of the most important elements on the periodic table, especially if you're you, right? Because we're human beings. Almost all of the molecules of our bodies have carbon in them, either as the backbone or as an important part of the molecule. So organic chemistry is super, super, super important, right? So everything that is living, almost everything that's living, is made with carbon. And organic in this case is referring to living, right? Living things. So that could be you. What's something else that's living? Give me some more examples of living creatures besides you. Some more examples of living creatures. Starfish, nice. That was a good one. Give me something else that's living. A sponge, yeah, like sponges. That's cool too. Yeah. Bacteria, right? Different form of life, right? Exactly. Sea sponge, good, good. Okay, yeah. They're all living, and they're all basically where organic chemistry touches upon those things. Sloths, yes. Humans, yeah, we can't forget the humans. Right. Okay, good. So we are carbon-based organisms, is what we would call ourselves, right? So we're carbon-based. There are a lot of science fiction. Well, some science fiction, they talk about other life forms maybe aren't carbon-based, maybe silicon or other elements in that same column that have similar characteristics to carbon that maybe could, in that case, they would be able to not be carbon-based, but it would be similar characteristics. If we went to one of those planets, though, sadly, we would probably starve to death, even if we were eating, because we wouldn't be able to digest it. So it would be a different form of life for us. Okay. All right.
All right, so we've all heard the word organic, right? And we've seen it in the grocery stores. We've seen it on TV. We've seen it in our food that we eat. But what do you think of when you hear the word organic? What kind of words come to mind when you hear that word organic? Farmer's market. Yep, good. What else? Forest, good. No chemicals, all natural. All natural, good. No chemicals, good. What other things do we hear of when we hear the word organic? Nature, good. Yeah, I like that, Morgan. Nature. Yeah, these are all special diets, good. Yeah, good. Special diets. All right. Yeah, all these things are great words for the word organic. Now, marketing has done a really good thing on this word organic. It does, to them, it's like all natural, no chemicals, nature, special diets, all this other thing, and that's what we think of when we think of organic. But really, organic just means living. That's all it means, is living. And so, but marketing, our modern marketing, has really kind of made it more of a health food thing. And but if we go to the store and grab a piece of, sorry guys, so when you look at the grocery store and you see those two heads of lettuce, they're actually the same thing. They're both living. They were both living things, and so they're both organic. But marketing has given us a different view on what organic means, and obviously has marked up the price when you go to the grocery store. So let's go ahead and talk about what really organic means. Organic means carbon-based. Anything we eat, anything we do is carbon-based. Organic compounds are compounds structured around carbon. Anything living or that ever lived, like our heads of lettuce when we go to the grocery store, or our apples, or our whatever we get, any type of fruit we get that was once living, is organic. Inorganic compounds are examples like silicon dioxide or quartz, aluminum, water, hydrochloric acid. Those are inorganic compounds. They are compound structures that do not have carbon. They are not carbon-based. Okay, so I want you to know the difference there. Organic compounds are carbon-based, that are structures around carbon itself that was once living or are living, and inorganic is that are not. Okay, they're just not carbon-based, and I gave you some examples there. All right, so let's talk about some carbon properties. Carbon is extremely versatile, meaning it forms millions of different arrangements. And why is it so versatile? Well, number one, carbon has those 4 valence electrons. Remember, valence electrons are those electrons that are floating on the outside, the outermost shell, right? And so it can create 4 chemical bonds, which is the max number of bonds with some exceptions. Okay, there are always some exceptions here. Okay. Number 2, carbon is small and can fit into parts of a very large molecule, while other atoms with 4 valence electrons are much larger and they cannot fit into other larger molecules, because then you just have this huge molecule. So carbon is really extremely versatile and very usable when you're talking about that. Well, this is going to be the answer to number 2, the word small. So go ahead and lock your answer in. I'm going to give you 20 seconds up on the clock. Raise your hand when you're finished. Thank you, Ileana. So let's go ahead and get our answers in. 20 seconds up on the clock. Go, go, go. Awesome. Thank you, Ashley. Excellent job. It's 13 seconds. Alejandra, Angel, Ashley L, Brianna, Erica, let me know how you're doing. Thank you, Ileana. I see you in the chat box. Kevin and Mario. Kevin and Mario. Perfect. Thank you, Erica. Awesome. So, still looking for Alejandra, Angel. Thank you so much. Ashley L, Kevin and Mario. Just a few more people left. Just a few more people left. Excellent. Let's go ahead and move on.
Okay, let's see here. Thinking back here. How many valence, I'm going to clear hands here, valence electrons does carbon have? How many valence are the outside ones, right? Just like a person, the most important part of the outside, well, that's not the most important thing in a person, but if you're going to shake hands with somebody, right, you care about their hands, right? You don't care about their liver or what's inside, right? So same thing here. So when atoms shake hands with each other, they grab onto each other, they do with their valence electrons. So how How many valence electrons does carbon have? I only see one answer. I got two answers. I want to see lots of answers in there, guys. All right, Haley. All right, Chantel. All right, Ashley. All right, Ziggy. Yes, Morgan. Yes, Angel. Nice, guys. Nice. Yes, and it does. It has 4 valence electrons. And that is actually going to be super important. And we're going to find out why. So there you go. So this is going to be the answer to question number 3. So go ahead and get your answers into your notes. I am, meanwhile, going to start the clock. 25 seconds, guys, and then raise your hands. All right, so let's see. Eric has, Ashley has, Ileana has it. Let's see who else here. Patrick, Angel, Haley, Morgan. Here's all the rest of you guys. Let's see. Kevin, did you get it? Yeah, okay, cool. Let us know. Anne-Marie, did you get it, Anne-Marie? Let us know. Anne-Marie, yes. Thank you, Anne-Marie. Like that. Thank you for raising your hand. Appreciate it. Okay, I'm missing anybody? Jalen, did you get it? Did you get it? Let's see. Okay. We do the chat box and the raised arms there. Okay, good. Okay, let's go on to our next one here. Okay, now fossil fuels. This is really what our society is still driven on. So fossil fuels are made of organic compounds called hydrocarbons. So hydrocarbons, right? And that's what makes up, well, they're made up of hydrogen and carbon. You can tell from the name, right? And this is pretty much everything that you can think of that, runs something. So coal, we don't use a lot of coal on the West Coast here. Petroleum, which is in gasoline. Oil, when you change the oil in the car. And then natural gas, like you turn on the gas stove, you turn it on, the natural gas comes out. It also, some people don't realize this, it also makes asphalt, like for our roads. It comes from, it's a heavier part of the petroleum that comes out of the ground. Fuel oil, gasoline, and then they take those same compounds and they use them to make plastic as well. So this is really, really, really important for our society, right? Wars that have been fought over these resources. So natural gas, for example, is mostly methane, right? It's usually a pretty good fuel for the most part. But it also can trap heat. Trap heat's more than carbon dioxide. So there's downsides to these things as well. So when something burns, it's going to be the hydrocarbons. It's going to be CH4 or C2H6 or whatever it happens to be, whether it's methane or ethane, etc. It combines with an oxygen, which is why you have to have oxygen for your fire. If you guys ever become firefighter, you'll learn about that. And it creates carbon dioxide, some water vapor, which people don't realize that fire creates water vapor. And of course, the most important thing we think of fire is what? What's the most important thing we think of fire? As a product of fire is what? What is it going to be, guys? I'm sitting here drawing. Okay, carbon dioxide is one of them. Good, right? What's the we think of normally? We think of fire. We're standing too close to the fire. What do we feel? Heat. Yeah, we feel heat. So that's the other thing too. It's an exothermic reaction. All right. So fossil fuels are extraordinarily important. Becoming less so very slowly with more solar and things like that, electric cars. But they're still going to be extremely important. Okay, let me go ahead and clear your hands, guys, and we are going to do this one together here. So let's see lots and lots and lots of lines up there. So I want to see lines from everybody, guys. Everybody go up to the top of your whiteboard tools, click on a color. You actually can click on the black one as well. It'll bring up some more colors. So I want to see lines from Aiden, Alejandra, Angel, Anne Marie, Ashley, the other Ashley, Brianna, Chantel, Erica, Haley, Jalen, Kevin, Mario, Morgan, Patrick, and Ziggy. So let's everyone put lines up there, guys. If you haven't done lines before, this is your time to draw your lines. Don't lose your chance to join the lines. Good choice there, Aiden. All right, let's see it here. All right, so this is going to be organic compounds. Organic compounds, yes, they are structured around carbon and living organisms. Okay, good. Inorganic compounds would be things like, everything else pretty much. So, you know, aluminum, water, hydrochloric acid, etc. Hydrocarbons are made up of only hydrogen and carbon, hence the name. All right, good. So go ahead and give yourself a pat on the back, right? And then raise that hand that you pat yourself on the back with, so we know if you have this in your notes. So let's get question number 4 answer. Thank Chantel, thank you, Kevin, thank you, Patrick. Okay, we are going to go on to our next slide here. Okay, we already got the correct answers because you guys got those right.
All right, so we're going to talk about carbon molecules. Carbon-based molecules are often structured in long chains called polymers. A natural example would be carbohydrates. So if you ever looked at a carbohydrate chain, it would be in a long chain, and that would be called a polymer. Now we have synthetic examples like plastic. So our plastic bags that we use at the grocery store, if you get them at the grocery store, obviously they're a little more thicker now because, we have to, they're supposedly reusable, so they're made a little thicker, but they're actually a carbon-based molecule. Polymers are made up of individual units called monomers. So if you look right here at our graphic here, the polymer would be that big molecule. Okay, would be that big molecule or carbon-based chain molecule. Whereas the monomer is that single individual unit. Okay, that are linked together, and so that's what make that. For example, octane is a component of gasoline and has a chemical formula of C8H18. So a carbon-based molecule has carbon in it, so it's one of those hydrocarbons. It is made of 8 repeating methane molecules linked together. Methane is the monomer. That's the smaller part. So methane is right here, and you have it linked in a chain, and so octane is actually the polymer, which is the larger part where you actually link those methanes together. Okay, so that's where you link all those methanes together and you get that chain of C8H18. Okay, that would be octane, whereas methane would be that monomer. All right, go ahead and just to kind of give you, just to kind of make sure we're all on the right track, go ahead and give me a green check if that makes sense. Monomers, you don't necessarily have to know methane and octane, but you know that the monomer is the individual unit. The polymer is that actual chain that with monomers connected together. Okay, think of it like Legos. The single Lego is not going to do much, but if I connect the Legos together, then I'm going to make whatever, a car, a treehouse, a whatever you're going to make, a spaceship, whatever. So that's exactly what it is. The monomer is the single Lego. The polymer is putting them all together. Excellent job, everybody. Nice, nice. So let's go ahead and take a look here. I want to check for understanding, and I want you to go ahead and use your whiteboard tools and box the correct word. Polymers are the what? Are they the small or the large molecules? Remember, long chains of carbon, so what would they be? Go ahead and take a moment and box that. We're just looking at the polymers right now. Good, excellent. I'm seeing, let's see who's up on the board here. Thank you, Morgan. Perfect. Let's get some more people up on the board. Good. Thank you, Ziggy. I see Ziggy up on the board. Let's get some different people up there. I will wait. We have plenty of time since this is an intro. It's kind of short. Thanks, Aiden. Awesome job. Awesome. I'm seeing Aiden up on the top one. Excellent. Thank you. Ashley's in the chat box. Beautiful. Let's get some more people up there. Alejandra, Angel, Anne Marie. Let's get some more of you up there. Thank you, Erica. Beautiful. Yeah, I do agree with all of you. And I'm going to go ahead and put your whiteboard tools on hold here. Yeah, polymers are those larger molecules where monomers are the smaller molecules, that repeating unit in that organic compound. For example, right here would be my monomer, just my single unit. This is my monomer. And this long chain here, this would be my monomer. This long chain here would then be my polymer. Okay. Polymer. All right, so there you go. So that gives you an example. I'm going to give you another 25 seconds to go ahead and lock your answers in. Raise your hand when you are finished. 25 seconds. Everybody should be, I'm giving you plenty of time here, so everybody should be raising their hands. Thank you, Ashley. I see you in the chat box. All righty. Let me just check in with a few people here. All right, still looking to see. Let's see. Ashley L. I see Ashley M, and I see Erica in the chat box, so I only have one person, Ashley L. Thank you, Mario. I see you up there. Excellent. Thank you, Kevin. I see you up there. Jalen, Morgan, awesome. Ashley L. Ashley. Let's go ahead and get our hand raised. Beautiful job, everybody. High five on that one. We have almost a 98% raise the hand rate. Good job. Beautiful. All right, let's go ahead and move on here. So we're going to talk a little bit about plastics. I'm going to go ahead and clear your hands here. Plastics are still considered what we call organic because they are synthesized from organic material like fossil fuels, which are mostly dead plants. Ethylene gas is naturally produced by fruits during ripening. How many of you have used perfect example would be avocados. Sometimes we get those avocados from the grocery store and we have to put them in the paper bag. Okay? With a few dinosaurs mixed in there, you got yourself some organic material, fossil fuels. Well, the ethylene gas from that fruit is actually being trapped within that paper bag, and hopefully it would ripen up those particular fruits. Sometimes what's better is to ripen pretty fast. Apples release a lot of ethylene gas, a lot of it, and so some people, what they do is to ripen up their avocados, they put an apple in the bag also, fold it up and kind of keep it there. It ripens it faster because of that ethylene gas coming off that apple. All right. Polymerization, many linked ethylenes monomers create a polyethylene, which is a polymer which equals plastic. It's all connects together. Here is the formula for ethylene if you look up here. Okay, C2H4. Now, as polymerization happens, you create this polyethylene, which obviously has all these carbons linked into a chain with those hydrogens also linked up there. So you're talking about a big thing, and then obviously it's synthesized into plastic bags. Okay, plastic bags. A little interesting fact right there. All right, let's go ahead and get your number 6 locked in. Let's get your number 6 locked in. This is the word synthesized. This is a big word. I'm going to give you 30 seconds to make sure you spell it correctly. 30 seconds up on the clock. Everybody should raise their hand. Awesome. Let's go ahead and just check in with people. So still looking for Alejandra, Ashley. Oh, no, Ashley, you're in the chat box. I see you there. And Erica, thank you so much. So looking for Ashley L. Jay Lind, Mario, go ahead and raise your hand. Those are my last 3. Thank you, Jay Lind. Looking for my last 2, Ashley L. and Mario. Mario, Ashley L. Go ahead and raise your hand. Excellent job, everybody. Let's go ahead and go over our last part here.
Okay, guys, so that's it, guys. That's it. So we talked about different types of organic molecules, everything from gasoline, petroleum, asphalt, etc. And monomers, which are single little small units, versus polymers, which are those long chains, things like proteins or polymers. You're made out of polymers mostly. Okay, let's see here how you guys are feeling. So go ahead and enable your whiteboard tools. Give me some feedback here, guys. Give me some feedback here. How you guys are feeling about this one? Okay, got some pretty goods, some awesomes. Okay. All right, guys. So just want to make sure that, make sure that you guys, I'm gonna actually go back to this. I want to underline this and make sure you guys understand this. So just remember, guys, that the final grade is going to be, the grades are going to be zeroed out. So if you haven't done something, 0 will be put in. That's actually a good thing, because that's basically the grade you will get if you do nothing else in the class. So when we zero out a grade, it's like, why did my grade go down? It's like, well, that'll be your grade if you did nothing else the entire rest of the trimester. So you'll be able to, everything that you do will actually bring that grade up. So just make sure that you check this afternoon. You'll find out what your grade is right now if you didn't do anything else. If it's below 60%, do everything that you possibly can to get that grade up so you don't have to repeat the class. And the biggest thing you guys can do are the projects. If you're missing a project, got to get that project in because you want to take the class over again and start over from zero and have to do a bunch of new projects. So make sure you guys check that. So check your grades, thing number one. And thing number two, if you're missing a project, make sure you get that in for sure, 100%. Does that make sense? Okay. All right, guys, that's what I got for you guys. Yeah, we can go back through the projects if you need help with that. And yes, Ashley, yeah, that's a really good question. When the work is zeroed out, that's designed actually to help you, even though you're like, why did my grade just go terrible? It's designed so you guys know what your grade would be if you didn't do it. So we actually do that on purpose. We don't want to like get to the very end and then put in a 0 for missing work and be like, wait, I suddenly failed the class. So yeah, you can do anything that's outstanding, anything that you haven't turned in yet, you can turn it in for sure. Yeah, zeroing out is just saying this would be your grade if you didn't do it. Yeah, once it's zeroed out, yeah, that's also a second really good question, Erica. Once it's zeroed out, like that's the least your grade's going to be. It won't go down after that. So anything you do, you're just going to be adding to it. So basically, what it does, it brings your grade down all the way down to like just what you've done, and then everything you do will add up. It can only go up from there. Yeah, we don't zero at the beginning of the semester because students don't want to be failing. They'll be failing from the beginning, right? So yeah. Good, yeah. Those are two excellent questions. I believe that is it. You guys can go ahead and submit your notes if you have them. If you need me to go back to a previous question, I'll be happy to do